Today we have to discuss resistors in series. First, I will tell you that resistors, they are connected in two ways in electric circuit. First is resistors in series, means resistor can be connected in series, and second is resistors can be connected in parallel. So resistors which are symbolically represented by the zigzag lines and resistor is denoted by R. It can be connected in electric circuit in two ways, in series and in parallel. So today we have to discuss how the resistors they are connected in series, or when we can say that the resistors are connected in series. So first we will see the statement that if the resistors are connected one after another or back to back, just like a chain. You know chain, that various rings they are connected one after another or back to back, we can say. In the same way, the resistors, when they are connected back to back or one after another, just like a chain, and carry same current flowing through all the resistors, that is same, but the potential difference or voltage, we know it is denoted by V. That potential difference or voltage across each resistor is different. I am again repeating the statement that when the resistors are connected back to back, just like a chain, and carry same current, means current flowing through them is same, but the potential difference or voltage across each resistor is different. Then we can say that the resistors they are connected in series. Now see this circuit diagram. Here the two ends of wire or conductor, they are connected to positive and negative terminals of the battery, from where voltage can be given. And we know that when two ends of conductor they are connected to positive and negative terminal of the battery, means voltage is applied. From battery we are taking voltage. As soon as voltage is applied, the current will start flowing through the conductor. Here voltage is applied, current I will start flowing through the circuit. Here we have assumed that three resistors R1, R2, R3 are connected in series. Let the potential difference across them, or voltage across them, is V1, V2 and V3. Let I is the current flowing through the resistors R1, R2 and R3 which are connected in series. We have assumed, we have to find out the equivalent resistance or effective resistance or total resistance of series combination of, here we have assumed three resistors. So that we will see here. Let R1, R2 and R3 are the three resistors connected in series. Let I is the current flowing through three resistors R1, R2 and R3. Here, see here, the current flowing through every resistor is same. Here current I is flowing through R1, I is flowing through R2 and I is flowing through R3. And here the potential difference or voltage taken by resistor R1. Here the total voltage supplied is V volts. We know that the unit of voltage or potential difference is volts. So here the total voltage supplied is V. Total current flowing is I. And here from this total voltage V, this R1, R2 and R3 they have taken different voltages V1, V2 and V3. We have marked V1, V2 and V3. We have not marked V. V1, V2 and V3 means the voltage taken by R1, R2 and R3 is different. So here we can say that these three resistors, they are connected in series, because here the current flowing through three resistors is same, I, and the potential difference or voltage taken by R1, R2 and R3 is different. Then we can say, and these three resistors, they are connected one after another or back to back. Here this combination of resistors, we can say that this is a series combination of resistors, or we can say that resistors are connected in series. So now here the total voltage is V, total current is I. What is the total resistance? Total resistance is the combination of these three resistors. Total voltage is V, total current is I. If we are discussing on total quantities in this electric circuit, then total voltage is V, total current is I, and total resistance will be the combination of these three resistors. We know that resistor, it is denoted by S. So the total resistance or equivalent resistance, we know that resistor, it is denoted by R. And as these three resistors, they are connected in series, so we have to pluck out this S from this word series, and we have to fix it to the suffix of R. If R is the resistance is denoted by R, and this combination is series, so R, yes. We will see here the expression for this equivalent resistance or total resistance or effective resistance. 2-3 words we can use for this, for our understanding. So we have to find out now the expression for equivalent resistance or effective resistance or total resistance. So see here. Here we have to find out the expression for equivalent or effective or total resistance of series combination of, here we have taken 3 resistors. If many resistors, number of resistors, 50 resistors, 100 resistors, they are connected in that same pattern, in same manner, back to back, one after another, and they are carrying same current, voltage or potential difference is different. V1, V2, V3, V4. If 50 resistors are connected, R1, R2, R3 up to 50, then that voltage across them is V1, V2, V3 up to V50, and current flowing through them is same. Current flowing through all the resistors, if they are connected in that manner, current flowing will be same, but the potential differences will be different. So that combination we call it as that series combination. And here now the equivalent resistance, we know that resistance, it is denoted by R, and here to the suffix of this R, resistance, S is fixed. That S is plucked out from the word series. For our understanding we can assume, and it is fixed to the base of that resistor R. So here from that circuit diagram, the total voltage supplied to the series combination of resistors is V. Total voltage is V. From that, R1 has taken V1, R2 has taken V2, R3 has taken V3 amount of volts. And if we combine that V1, V2 and V3, that will be equal to the total voltage supplied to the series combination of that 3 resistors. So here total voltage is V, and that will be the combination of V1, V2 and V3, means that 3 resistors they have taken V1 amount of, V2 amount of and V3 amount of voltage. So here V is equal to V1 plus V2 plus V3. Then put this as equation number 1. Then V, we know that Ohm's law. We have studied. Yesterday we have studied Ohm's law. That Ohm's law, it represents the relationship between voltage V and current I. And voltage is directly proportional to current. And then finally we have got the expression V is equal to IR. So by Ohm's law, V is equal to IR, we know. Then to find out this total voltage V, we have to assume the total quantities in that electric circuit. Total voltage is V, total current is I, then total resistance is the combination of that three resistors. As that three resistors they are connected in series, we have assumed RS as the effective or equivalent or total resistance. So total resistance is RS, total voltage is V, total current is I. Then what will be that quantity V? V is equal to IR. That is the formula or relationship by Ohm's law. So V is equal to I, total current, and total or effective resistance is RS. Then in the similar manner, if we want to find out V1, V1 is the potential difference or voltage taken by resistor R1. Resistance is R1, current flowing is I, and potential difference or voltage is V1. So that V1 will be equal to the product of current and resistance. So current flowing through R1 is I, and current resistance is R1. So V1 is equal to IR1. V2 in the same manner, V2 is nothing but the potential difference of voltage taken by resistor R2 and current flowing is I. So V2 equal to IR2, V3 is equal to IR3. If we put V is equal to IRS, V1, V2 and V3 in the equation number 1, that V is equal to V1 plus V2 plus V3, that V is equal to I into RS. In this electric circuit which we have assume the three resistors they are connected in series, then V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3, then I will be common. Then this I in the bracket R1 plus R2 plus R3, this I will get cancelled and we will get this expression RF, which is the equivalent resistance or total resistance or effective resistance of series combination of three resistors. And R1, this RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. This is the expression for equivalent resistance or effective resistance, or for our understanding the total resistance of series combination of three resistors. Here we have assumed three resistors. If we assume 5 resistors, RS will be equal to R1 plus R2 plus R3 plus R4 plus R5. If n number of resistors we have used, then RS equal to R1 plus R2 plus R3 plus dash 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 plus RL. So what we conclude from this, that in series combination the resistance is increasing. If we add 3 resistors instead of 3, if we add 10 resistors, then resistance is increases of the electric circuit. That resistance is increasing. Means what? We know that resistor is a device which opposes the flow of current. If the value of resistor is more, current flowing will be less. If the value of resistance is less, more current will flow. Means what? This series combination of resistors, it decreases the current. Whatever we require in any application, if we require current should be less, then we can use more resistance in the same pattern, back to back, one after another. Then current will be decreased. So this type of combination of resistors is used to in the specific purposes where the less amount of current is needed. So that's all about. So we will stop here. Now we have completed resistors in series and that equivalent resistance expression for that equivalent resistance. Okay.